is at your pods, I would like you to talk about different strategies that you use to solve any puzzle or any problem, whether it be like a non-math related puzzle or a math related puzzle or problem. Just talk about strategies that you use. You have 30 seconds. All right, pad one. Give me one strategy. Okay. Do what you know first. Pad two.
Organize their pieces.
Or you get organized. Okay. Pad three.
Corners and edges first.
Okay. So do the easy part first.
So look at like he's looking at it from like a whole side.
Pad four. Pad four. Guess and check. I like that. Pad five.
Just force the pieces together. Make it work.
Make it work. Okay, you guys took me very literal with the puzzle thing. I'm not necessarily talking about a jigsaw puzzle. This is true, I did say any puzzle. Okay? But you have lots of problem solving strategies that you have talked about since you were a wee child, right? You guys have talked about problem solving forever. Well, hello. Thank you.
You guys go around to school.
Okay, today we are going to learn the fundamental identities. Basically, this is where trig meets algebra, this chapter. Okay, the first part of the chapter, we're going to talk about identities and showing that identities are true. And in the second part of the chapter, we're going to talk about like solving equations. Okay, so today we are going to write down the fundamental identities, and then I'm going to show you how we can use them to substitute and change the way that something looks. Okay? So, what's nice is at least two of the three identity groups you kind of already know. The first group is the reciprocal identities. We're talking about trig, and up there is written reciprocal identities. What do you think we're going to write up here? Okay, and so secant, what's the reciprocal of secant? Cosine. And what's the reciprocal of cosecant? Sine. And the reciprocal of cotangent? Tangent. So we're going to write that the sine of theta is the same as 1 over the cosecant of theta. And that the cosine of theta is the same as 1 over secant theta. And tangent theta is the same as 1 over cotangent theta. Similarly, we can also write that the cosecant is the same as 1 over sine. The secant is the same as 1 over cosine. And the cotangent is the same as 1 over tangent. Okay? We essentially have three reciprocal relationships that we can write out 6 different ways. Okay? I will tell you, we have a quiz. We have a quiz next week. On Thursday, this will be the first question. What are the reciprocal identities? The second question on your quiz, what are the quotient identities? Quotient means what? Ooh, division. Do we know of any trig functions that we use division to find? Yes, you do. Not those ratios. I like where you're going. I'm thinking more of a trig function where we have to like divide two others.
Oh, tangent.
And what is tangent? Sine over cosine. Okay, tangent, we take y over x from our unit circle, which is the sine over the cosine. Okay. Similarly, the cotangent from our unit circle, we like to take x divided by y, which is the same thing as the cosine over the sine value. So those are our two quotient identities. Question number 2 on your quiz. And then question number 3, the Pythagorean identities. Don't draw this up here. Just watch me. This is the unit circle. What's the radius of a unit circle? 1. This side is x. This side is y, right? Pythagorean theorem says that x squared plus y squared equals hypotenuse squared. So tell me this. What does x stand for on our unit circle? And what does sine stand for on our unit circle? Oh, should I say that backwards? What does y stand for on our unit circle? The sine. So cosine squared plus sine squared equals what? And you know what? I know I have it written that way, but I'm going to just tell you, you're going to see it as sine squared plus cosine squared. So let's go ahead and write it down that way. I'm sorry. You're going to see it like that. And so we might as well just get used to that. Sine squared theta plus cosine squared theta. Okay? And when I say theta, as long as the angle is consistent, these identities work. So if it's sine squared x plus cosine squared x equals 1, that's fine. Or beta, or alpha, or 2 alpha, or 15,000 degrees, whatever it is. As long as the angle is the same, these work. Okay? Now, don't write this down. I just want you to, what I write in green, you're not writing down. If I divide everything by sine squared, what is sine squared divided by sine squared? Okay. What about cosine squared over sine squared? What's cosine over sine? Cotangent. And what is 1 over sine squared going to be the same as? Cosecant squared. So please write that identity down. This is the second Pythagorean identity. That's how we get it. You can either remember how we got it, or you can just remember it. 1 plus cotangent squared equals cosecant squared. No. Okay, once again, in green, Don't write it down. Let's divide everything by cosine squared. What's sine squared over cosine squared going to be the same as? What about cosine over cosine squared? 1. And 1 over cosine squared is the same as secant squared. So these are your 3 Pythagorean identities. That'll be question number 3 on your quiz. Okay? You basically need to know these 3 groups of identities to be able to do anything in this chapter. I don't want that to scare you. I want that to prepare you. And really, if we really think about it, these Pythagorean identities are probably the only ones that we didn't already kind of know. Right? The other ones, I mean, we didn't officially write them down, but we've known that those are the relationships. Okay? So before we go to lunch, we are going to practice factoring trigonometric expressions. So go ahead and write secant to the 4th x minus 1. Okay? If you can do algebra, all we have to do is apply it now with trig functions instead. Okay? Now, if you have a hard time seeing how to factor, you can always do some scratch work off to the side. If you need to write this as s to the 4th minus 1 so you can visualize what's happening, how do we factor something like that? What's that pattern? Difference of squares, right? So we have s squared minus 1 and s squared plus 1. Do you agree? Okay, so we can come over here and we can factor secant to the 4th x minus 1 as secant squared x minus 1 times secant squared x plus 1. That's how we would do that. Yes?
Can you factor it further then?
We could. Okay. Factoring it further. Now, if all I was asking you to factor, yes, we could go ahead and factor this to secant x plus 1 times secant x minus 1, and then we have secant squared x plus 1. Yes, we could do that. All right, one more before we go to lunch. Here I have an expression. What kind of an expression is it? Yeah, I know it has tangent in it, but disregarding the tangent, what kind of expression is this? It's a quadratic, okay? We have a trinomial. So if you need to off to the side write this as 4t squared plus t minus 3, you can, okay? You gotta factor this. We know we're going to have a 1 and a 3 here, right? Okay. If we have 4t times 1 and t times 3, if we make the 4t positive and the 3t negative, does that work? We can always check, right? We can always FOIL this out to make sure we get back to the original. Okay, so you don't necessarily have to do this. You may be able to just do it over here. But since 4t squared plus t minus 3 factors to these two binomials, then we can say that 4 tangent squared x plus tangent x minus 3 factors to tangent x plus 1 times 4 tangent x minus 3. We haven't even used any of those identities yet, I know, but if we can get just exposed to factoring right now, it'll help us next week when we start solving equations, okay? So right now I'm going to go ahead and let you go to lunch, and then when we get back, we'll practice using those identities, okay? So now what we are going to do is we are going to take expressions and we are going to simplify them using our identities as well as common algebra skills. Okay, so everyone go ahead and write down this expression. And we need to simplify it. So, any ideas on something that we can do, either related to our identities or algebra? Darby,
No.
say what you're going to say, though.
Divide it by sine of x.
Okay, so I like that you picked out that sine of x. We can't just divide by something because it's not an equation, but you're noticing that there's a sine of x in each term, right? So instead, what could we do since there's a sine of x in both terms? Instead of divide, we can factor it out. Okay, so something you can look for, is there a common factor? Okay, so we have a common factor of sine of x, which means we can factor it out, and left over we have 1 minus cosine squared of x. Okay, okay. Now ideas. That does follow a difference of squares pattern. However, that's not going to make it simpler. Okay? I like that thought. All right? How can we make that simpler? Okay. I wrote something on the board that could be helpful. Do we have an identity that relates cosine squared and 1 together? Okay, we have an identity. Sine squared plus cosine squared equals 1. So technically, sine squared is 1 minus cosine squared. If we move that over to the other side, okay, we can rearrange an identity to use it. Okay, so if sine squared is 1 minus cosine squared, right? What can we replace that with? Sine squared. Okay, so ultimately we can say that this is sine cubed x. And that is a much more simple expression than what we started with, which is our goal. All right, let's try another one. Okay, at your table, take about 30 seconds and discuss any ideas you have about making this simplified. idea is a bad idea. Okay, now that you've shared ideas at your table, is there anyone brave enough to share the idea that they have? Caroline.
Well, cosine of x is the same as cosine of x over sine of x, so then you have more like harmony.
Okay, so Caroline is suggesting we take cotangent and rewrite it as cosine of x over sine of x. So now everything is just cosine and sine. I like that idea. Okay? That's a strategy that we're going to talk about on Monday. But getting things to all be sine and cosine can be a helpful tool. All right? So let's talk about what we have now. We have the sine of x plus, if we multiply, this is like cosine over 1, essentially. So what we have is cosine squared x over sine of x. All right, we need to keep going. How can we make this even more simple? Okay, any thoughts? We multiplied this up to here. We multiplied cosines together. And then sine.
I had an addition column.
Darby?
Maybe if you get it so that sine of x has a denominator of sine of x, then you can add them together.
Okay, good. Anytime we're adding two expressions together, if one is a fraction, in order to be able to add or subtract them, the other one needs to have the same denominator. So, in order to create like denominators, we can multiply the sine of x by sine of x over sine of x. So then we can have like denominators. Okay. So then when we add these two together, we have sine squared x plus cosine squared x all over sine of x. Connor, yes, sine squared plus cosine squared equals 1. That is something that by the time you come back on Monday needs to be like an aha moment. When you see sine squared plus cosine squared, it is 1. Yes, and then 1 over sine, we can write even better, cosecant of x. Look how we took something very complicated and we whittled it down to just cosecant of x. What? There's no, you like that? Okay, good. Well, then you'll like the next few days. Okay? Now, some of you may become a little bit frustrated because you don't really know when to stop. Okay? I'm just going to tell you to get through this assignment, and then on Monday, we're going to actually have knowledge of when to stop, when we get to the end. Okay? So we kind of have to go through the motions today, but I promise on Monday and Tuesday when we do those lessons, it will be way better because we'll actually have an end in sight, but we have to start with this stuff. Okay? Two more simplifying examples. Here's example number 3. What? Looks could be deceiving. Okay. I basically want to talk about this one so you can see some different things that could happen. Okay. Now, when we have a denominator like this, 1 plus sine of x, okay, a strategy that we have, and we'll talk about this strategy again on Monday, but we can also always multiply numerator and denominator by a conjugate. Do you remember what a conjugate is? that would not be the conjugate. What would its conjugate be? If this is 1 plus sine of x, its conjugate would be 1 minus sine of x. Okay, so what we're going to do is we're going to multiply by the conjugate of the denominator. Okay, well, Mrs. Holman, why would we do that? Okay, this gives us a numerator of 1 minus sine of x and a denominator of 1 minus sine squared of x. Okay, so Connor did a good job in that last example picking out sine squared plus cosine squared because that equals 1. Now another thing that you need to be on the lookout for is when 1 is grouped together with cosine squared or 1 is grouped with sine squared. Okay? If you rearrange this formula, 1 minus sine squared is the same as what? Okay, if we subtract sine squared to the other side, 1 minus sine squared is the same as cosine squared. Yes.
Steph, could you also have, it probably wouldn't have helped, but could you have subtracted, like, the exponents, could you have had, like, technically a sine to the 1?
No. Because we have two terms in the denominator, we can't split them up. That's a good question, though. So that's a misconception that will reoccur. Okay? We can't split the fraction up because we have two terms in our denominator. We can't simplify unless we have a common factor. All right?
Alright, so like the first step, when you need to FOIL those, not the...
Yes, and when you FOIL these, you get the difference of squares.
Okay.
Because it's 1 plus sine, 1 minus sine. But yes, you would FOIL to get here. Okay? Now, we have this fraction here. Since we have two terms in the numerator and only one term in the denominator, we are allowed to split fractions apart. Do you agree? Okay. So what we can do is we can write this as 1 over cosine squared minus sine of x over cosine squared. Okay? I wanted to do this example so you could see that that is allowed. We can split things up using the denominator. Okay? So 1 over cosine squared, can we write that as something different? Okay, what can we write it as? Okay, 1 over cosine is the same as secant, so 1 over cosine squared would be the same thing as secant squared. Now this fraction here is a little bit more complicated. My suggestion to you, okay, sine over cosine squared, there's like an extra function in the denominator. So we can break this up to sine over cosine, okay, because we know that can simplify to something. But then that leaves an extra cosine in the denominator, so we can write it as sine over cosine times 1 over cosine. So what we get is secant squared x minus tangent x secant x. What? It's right for the scenes. Okay? Now, some of you may be uncomfortable. Like, I don't feel like this is any simpler than what we started with. And you could make that argument, okay? But right now we are practicing, just changing one expression to another, okay? All right, with your thumb, up, middle, down, how's this going? Okay, okay. If you feel right here, you're fine, okay? We're gonna keep working. You got something to say? No? Okay. All right, write this one down. two fractions. Sorry if that's unclear. Okay, we are adding two fractions together, which means we need common denominators, okay? Anytime you see two fractions being added together, or two expressions being added together and one's a fraction, we need to just make common denominators so we can switch them together. Addition or subtraction, okay? So this has a denominator of sine of x, this has a denominator of 1 plus cosine. There's nothing similar about that, okay? So we'll take this first fraction and we'll multiply by sine of x over sine of x. And then we'll take this second fraction and we'll multiply by 1 plus cosine of x over 1 plus cosine of x. So then when we add these two fractions together, we have 1 plus cosine of x times sine of x as our common denominator, right? Here we have sine squared plus, here we have cosine of x plus cosine squared x. All right, look at that fraction in the numerator. Do you see anything that jumps out at you? Carolyn?
Sine squared x plus sine squared x equal 1.
Yes, we have sine squared plus cosine squared equals 1. That is going to pop up a lot. You need to really get used to recognizing it, okay? So what we have is 1 plus cosine of x all over 1 plus cosine of x times sine of x. Is there something the same in the numerator and the denominator? Yes, there is. These are factors that we can cancel to be left with 1 over sine of x. Taden, what is it?
It is cosecant.
Good. Okay. Now, I know some of you aren't 100% sold, which means it is vital that you do your homework this weekend. Okay? You have to practice this. Now, there's one more thing that I'm going to show you, and then I will give you your gold sheet for the chapter so you can see your assignment. Okay? So you're going to have 3 types of problems tonight. The first is going to be factoring, so you can practice that skill. The second, and the majority of your assignment, is going to be this skill, simplifying. And then the third kind of problem you're going to see is something like this. So this is what I need you to write down. Write down that x equals 2 tangent theta. And then write radical 4 plus x squared. Okay, so what we're going to do is we're going to take this radical 4 plus x squared, and we're going to use trig substitution to rewrite that in terms of theta. Okay, so they have given us that x is 2 tangent theta. So I'm going to replace x with 2 tangent theta. then we can go ahead and square it. So what we have is 4 plus 4 tangent squared theta. Okay. Now, I notice that there is a 4 in common with both of those terms underneath. All right? So what we can do is we can factor out a 4, so that left over is 1 plus tangent squared theta. Now, why did I do that? 1 plus tangent squared theta, is that something special? What is it? Say louder. It is secant squared theta. That's one of your trig Pythagorean identities. Okay, so we can factor out that 4, which means we have 1 plus tangent squared. We change that to secant squared, and now we can say, okay, the square root of 4 is 2, and the square root of secant squared is secant theta. Okay, I'm handing out the gold sheet for your chapter 5. It is a very short chapter. There's only 4 sections. Okay, so you'll see that we have a quiz next Thursday, a quiz the following Wednesday, and a test the following Wednesday. Okay, so if you're at home, 21, 23, 25. This is the homework. This just doesn't have the bolded problems. But this is your homework.
We have Monday.
Yep.